Kim,
Yes.
I could start reminding you for recording. Is that what you were talking about?
Yeah.
Yeah, I could start to remind you if you want.
Thank you.
You're welcome.
Okay. Last week I asked you bring a topic for your project, but let's do that discussion after the lecture. Okay. Okay. Today, chapter 4, forecasting. In operations management and further whatever company, like a production company, manufacturing company, or a service company, whatever company, why they need this forecasting in operations management perspective? Any idea why forecasting is important in company?
This is Ryan. I would say primarily because it is their opportunity to match the volume that they anticipate with the capacity. So often
Right.
that's people processing something.
This time, last night about 2:30 a.m., I watched CNN, and then that electional, the presidential election voting. Before that, many researchers predict, forecasting who win which state, and so on like that. So that also forecasting. So forecasting is important in company, whatever production, manufacturing, or service, because like a capacity or a demand. So if we forecast the demand, future demand, based on that demand, we can plan, schedule, and so on like that. So forecasting is important. By the way, Pennsylvania currently about 300,000 difference. President Trump and Biden. Last night, I used the information, and then I forecasted about 600,000 difference. But then my forecasting was wrong currently. Okay. Anyway. Okay, because of demand, forecasting is important. So demand management. Purpose of this demand management, purpose coordinating and controlling all sources of demand. So the productive system can be used efficiently, and the product delivery on time. So delivery on time, and then efficiency matter. So if we forecast the future demand, then we can prepare the capacity. Then we can match that like optimal capacity, and efficiency improve. There are two types of demand, dependent demand and independent demand. I don't know if I did this one earlier. A final product, and then the part product. I usually do a car. So tire as part. So if we know final product demand like 1,000, then automatically we know the tire product, not include the spare tire, then 1,000 times 4, and then 4,000 tire we need. So based on this final product demand, we can get this part demand. So final product demand is independent usually, and then part or component material demand is dependent demand. Okay, next, components of demand. Average demand, like an actual demand move like this, up and down like this. Then average, so add all actual demand and then divided by the number of terms, then this is average. So average demand like this. And then seasonal elements, up and down, same pattern. If like ice cream demand, usually during like in the spring, summer, and then fall, and then winter. Then ice cream demand usually like this, and so on like this. And then next year, the same pattern come again. Next year, come again, and repeat the same pattern every year. Season by season, the same pattern come again and again. That is seasonal element. And the cyclical element, like in a financial market, not follow like every year, not every year, but maybe 3 or 4 years come the pattern again and again. That is a cyclical element. So more than like 2 or more years, the same pattern come again and again. That is a cyclical element. And then a random variation. There is no pattern, just move randomly. That case, we can say random variation. And then trend. For this example, up and down, but long-termly, it increase. So this case, this example, increasing the trend, maybe decrease trend. So that case, negative trend and then a positive trend. And then maybe stable. So there are 3 types of trends: decreasing, stable, and then increasing. Something. My speaker connected. What is that? The Bluetooth, and it says something warning, like a battery. Okay. Okay. Next one, types of trend. Linear trend, just in a straight line. As I mentioned, this trend can be increasing trend, decreasing trend, maybe a stable trend. And then like an S-curve type, looks like S-curve. Then this is the kind of part of, the product life cycle. There are 4 phases. Oops. So first phase is introduction phase, and then growth, and then mature, and then decline. So this part is about here, like from here to here. So typical product life cycle trend is like this. And then this one and this one, asymptotic and exponential trend. I can ask a question, which one, this one or this one, which one is for the new product trend? asymmetric, or exponential. On this part, product life cycle, this part, the introduction part, first time, increasing rate is not much, but later increasing rate, increase, and so on like that. So this one, exponential trend, the beginning part, increasing rate is not much, but later increasing rate is high. So this one, exponential trend, is typically a new product trend. And then this one, asymmetric, maybe already mature or already in a saturated product in market. Next, types of forecasting. There are two types, qualitative and quantitative. Qualitative, without like numeric data, we can forecast using subjective and judgmental opinion. When I was in Alabama, then I know Hyundai and Kia people. Then I asked them without maybe without numeric data, just asking, what do you think about next year's demand? Then at that time, they expected like 10% increasing demand next year. So without previous or past data, just they expect, because they work at Hyundai, and then so based on that opinion, if I'm a dealer or if I'm a supplier, then based on that opinion, we can prepare 10% increase in capacity. That is qualitative forecasting. And then quantitative forecasting, there are two types, time series and then causal relationship method. Both are based on regression analysis, using past data, numeric data, and then predict future demand. So using this time series, maybe causal relationship tool, determine a trend, seasonal and cyclical pattern. Then using that pattern, we can forecast future demand. And then this one also similar. Difference between time series and causal relationship. You know, using this method, we usually develop equation like y equals a plus bx. So this is dependent demand, then this is independent demand or independent variable. So using this independent variable, we can forecast. Then y variable and x variable. If x variable time related, like a first month, second month, 3 months, third month, and then fourth month, and so on like that. So if x variable related time, if time change, then x variable change. That case, we call this data as time series data. So if we use time series data forecast, that is time series analysis. If like ice cream demand and then temperature, so temperature and then ice cream demand, the temperature increased, then ice cream demand increased, temperature decreased, and ice cream demand decreased. So there is something cause and effect relationship. So x variable and then y variable. So x and y variable has something correlation. Then using that correlationship, find determine or forecast future demand, that is causal relationship method. Anyway, both use regression analysis. I will show you later. And then more in detail, qualitative techniques in forecasting, judgmental method. Just mentioned earlier, the same, based on a process of collecting educated opinions from individuals or a group. So ask 100 people, maybe a dealer. So ask them, then based on their opinion, we can forecast without numeric data. So using a jury or executive opinion, like a CEO or the higher ranked people at the company, maybe they have internal information. So using their opinion. Sales force, like a dealer or sales department personnel, ask them, and then based on their opinion, then forecast. And secondary source of information, there are so many sources out there, internet, network, and so on. So using others forecasting, like a consumer market survey and so on, then use their opinion or data, then forecast. And then Delphi method, this one is similar to judgmental, but using a group of experts to make a team, like bring them like practitioner, researchers, and so on, economists, and so on. So make a group of experts and then ask them and their opinion. Based on their opinion, using like a survey, then using their opinion, then if we can have data based on this opinion, then use time series or causal relationship, then forecast. That is kind of steps for Delphi method. Okay, example of time series analysis, quantitative method. A simple moving average, just add previous data and then divide by the number of terms, and then using that average for the next terms forecast. So if we use 3 weeks, 3 terms, simple moving average, then add 3 previous, 800 plus now 1400, and then 1000 divided by 3, that is 1067. If we want, it's like if I write a formula equation, then maybe, no, not maybe, absolutely. F, this is 4 equals A3 plus A2 plus A1 actual, and then divided by 3. That will be 800 plus 1400 plus 1000 divided by 3. That will be this one. And then next like this. This one is F5 equals A4, A3, A2 divided by 3, that one, and so on. And then if we use a longer term, like 9 weeks, then add all previous 9 weeks actual divided by 9, and this one, and so on. So that is that. And also, looks like this, actual, up and down like this. And then if we use 3 weeks simple moving average, and then longer term, 9 weeks, and then using more terms or period, then is more smooth, flatter. And also this one, simple moving average technique can be used to forecast, and also this like a smoothing technique for if we use this raw data up and down much to forecast using time series or other numerical method, then the result may be not accurate. So using smoothing method, make it smooth, and then using this smooth data for forecast. This time, every state report daily the positive case. Some states report 3 rolling day case data. So average 30 days, and then report 30 days report like that. And then some cases they use 7-day moving average forecast report the case. Because for my research too, if the test number increase and then the case decrease, then there I found that there is pattern. During the weekday, the number of tests increase, and then weekend decrease, and then weekday again increase, decrease. So based on that, like a relationship, there is pattern to that kind of fluctuate, decrease that fluctuation using 7-day moving average, then is more smooth data. So using that smooth data forecast, then maybe the result more accurate. So this moving average technique can be used in forecasting itself, maybe make it the data smooth. And next one is weighted moving average. Earlier one, simple moving average. When we get that simple moving average, then simply add and then divide by the number of terms. Then let's see like this. If it is 9 and 10, 11, and then using that 3 terms, then 9 plus 10 plus 11 divided by 3 equals 10. This means 9 times 0.333 plus 10 times 0.333 plus 11 times 0.333. So to make this result, this one's row, this one's row, this one's row the same, because this is simple, add simply and then divided by the number of term or period. So their row or weight are the same. That is a simple moving average. But sometimes certain terms importance is more important. That case give more higher weight. So for this example, the idea is recent data more important. So the most recent data give highest and the next and so on like that. So with that idea, give 0.4, 0.3, 0.2, 0.1. The sum of all weights equals should be 1. So 0.4 plus 0.3 plus 0.2 plus 0.1 equals 1. If we use now 5 terms, then maybe I can give 0.4, 0.3, 0.1, and 0.1, and 0.1 like this. Is it right? 1, yeah. So whatever terms we use, if we give the weights, then the sum of weights should be equal, not L, 1. So with that idea, most recent term, month 4, when we forecast month 5, month 4, 0.4, month 3, 0.3, month 2, 0.2, and then 0.1. Then we can get this forecasting for F5. Okay. Okay. Clear. Excuse me. By the way, example using Excel. The file is on Moodle. This one. So open this one. Okay, I will give you open that download and open that file. Let's do together. When you are ready, you know, when we go like a restaurant or somewhere, and then like what is that now? Olive Garden, then order whatever, then they ask a soup or a salad, then salad or soup, then they bring a cheese, and then say when, then say when, like that. Say when, when.
We're good.
Okay, say when.
When?
Okay. Thank you. Okay, example number 1, same question. So using it, very simple. So, you know, F4 using the 3 weeks, just click that cell and then equal. Then I use function sum. Then previous, not here, here. 3 previous, enter. What the? Not sum, average. I'm sorry. not sum, average. Sum divided by 3, but using an average. And previous 3 terms, enter. And then just double click when, like this. Either way, fine. Move cursor, drag down, or just move cursor, place right bottom, then double click, then automatically change. And maybe I can change decimal point like this. And the 9 terms, tens equals average, then previous 9 term, enter, and then again double click and done. Easy, right? So using Excel, we can get like a smoothing data or forecasting easily and then fast. Okay, next one, we done weighted moving average. And then kind of practice using the same weight, then 110 times 0.4, 95 times 0.3, 105 times 0.2, and then 90.1. And result is 102.5. Okay, that is weighted moving average. We give weight like arbitrary based on like the experience or whatever. Then the same idea, using the same idea, the most recent occurrence are more indicative of the future than those in the more distant past. Using exponential kind of constant. So using exponential constant, alpha 1 minus alpha, the terms power, the 0 term 0 power, first term 1, 2, and so on. So using this kind of weight, exponential smoothing weight, then we can forecast. Formula, by the way, alpha is given. So if use lower value of alpha, then more smooth, flatter. Higher alpha, closer to original raw data. So we call this alpha as smoothing constant. So lower, smooth, higher, closer to original data. And then using this formula, term T's, like if we have 10 months data, and then if we forecast 11s, then 11 forecast equals forecast of 1 term earlier plus given alpha, smoothing constant, and then actual data 1 term earlier minus forecasting 1 term earlier. So if, example, the last month is forecast equals 22,000 loaves. Earlier, I mistyped, omit A. So it was like 22,000 loaves, so many loaves. I'll add A. And then 21,000 lobes were actually demanded and alpha equals 0.01. So this one is using pen. So this last month is forecast. So this is F T minus 1. And this one actual. So A T minus 1. Then alpha. So plug in. Then Ft minus 1, 22,000 plus alpha is 0.01, then times actual T minus 1, 21,000 minus forecast T minus 1 and calculation, and then 21,990 lobes. So term T's forecast. Okay, there is a problem. If we use this exponential smoothing forecast, problem is lagging behind problem like this. If we use this exponential smoothing technique, then higher alpha smoothing constant, then the actual data peak is here, highest peak is here, but this one about maybe one term later, lagging behind, and then lagging behind like this. So that is kind of lagging behind is kind of error, mistake. So to correct or fix that problem, we use one more smoothing constant. That is delta. So using delta, and then use kind of trend, and then offset that error, try to offset or fix that error. And then a little bit more complicated formula. FIT, forecast including trend, equals FT plus PT. And then this one, FT, forecast and the term T equals FYT, one term earlier, plus alpha, actual, one term earlier, and then FIT, one term earlier. And then TT, trend, in term T, TT equals trend, one term earlier, plus delta, then FT minus FIT, T minus 1. FT, after calculation, this one, plug in, and so on. So example, if F11 is now 100, and then T11 equals now 5, alpha equals 0.1, delta equals 0.3, A11 is now 110. Then this one asks, calculate FIT 12. So I will write down FIT 12 equals F12 plus T12. And then F12 equals FIT, one term earlier, so 11, plus alpha times A11, one term earlier, minus FIT 11, one time only. T12 equals T11 plus delta times F12 minus FIT 11. So we have F11, T11, alpha, and so on. So I will use other color. So we know T11, we know alpha, we know delta, and then A11. But we don't know FIT11 is not given. So from the idea, FIT T equals F T plus T T. So if T equals 12, then FIT 12 F12 plus T12. We don't know FIT 11, FIT 11, that will be F11 plus T11. So F11 and T11 given, so FIT 11 equals 100 plus T11, 5, so 105. So we know FIT 11, so we know that. So all required data we know. And then this one, after calculation, then plug in. So plug in everything, and then we can get like this. So FIT 11 is 105. So plug in 105. Alpha is 0.1. A11 is 110 minus 105 equals 105.5. And then T12, T11 is 5. And then delta is given 3. And 105.5 minus 105. This one from this calculation, 105.5. And minus 105 equals 5.15. So FIT 12 equals F12 plus T12 equals 105.5 plus 5.15 equals 110.65. Okay, if we use the formula and the hand calculation, then somewhat complicate. So I will show you how to use an Excel. So open this now file again, and example 2. Say when.
When?
Okay, thank you. Okay, use the pen. Okay. This one, actually this one equals FIT. Let's say January is 1. And then this one is FIT 2 and FIT 3 and so on. And then this one is F1. This one is T1 and so on. So FIT2 you need FIT2, then that will be FIT 1 time earlier 1 plus alpha, and then A1 minus FIT 1. And then, no, FIT 2 equals F2 plus T2. So this one is F2. And then T2 equals T1 plus delta F2 minus FIT 1. So this one equals this one. So I will type in, so this one equals this one plus this one. So equals FT plus TT, enter. Now we don't know yet, 0, because we don't know F2 and then T2. So F2 equals FIT1. So this one is FIT1 plus alpha down here. We will use this alpha again and again, so make it absolute reference by type push F4 key, function 4, and times alpha times open parenthesis, and then A t minus 1, that is A1. So this one is A1 actual. So this one minus FIT 1. So this one again. Click this one and then close parenthesis, and then enter 11.8. So I will show you like a function formula. And next one equals T2, that is T1 plus delta. So this one, make it absolute, because we will use that one again and again. And then times, parenthesis, then FT is this one. And then minus FIT earlier one, this one. And enter, done. And then copy all the way down. Done. So based on this, we can get F December IT, let's say 12 or December equals 28.27. Can make this so if you fill in those box with the formula using a function, then just copy all the way down, and then that's it. What do you think? Doable? Okay. Okay. Yeah. Do you have a question? Okay. I'm hungry. So snack break until 7. I'll be back at 7. Okay. Take
Okay, sounds good.
Sounds good.
I'm back.
Welcome back. How was your snack?
Yeah, very quick. uh, the tomato and orange juice blending, and then a small muffin. It was very
Excellent.
eat fast. Okay. Next one. Linear regression analysis using regression technique. Then we can use past data, quantitative method. Regression of functional relationship between two or more correlated variables. Then using a least square method. Least square method is if data, actual data, like this, then using actual data, then develop this forecasting line, straight line. So this least squares method is try to minimize distance between forecast and actual. So actual minus and square, actual minus forecast square. So distance square, and then try to minimize that distance using derivative. And we don't care about how to use that derivative mathematically. So using that squares method and then derivative, then we can find equation. So a depth slope, using that, and we equals sum of x variable times y variable minus n is sample size, and x bar is average of x variable, average of y variable, divided by sum of x squared, x squared minus sample size, then x average x of the square. And after we get slope, and then intercept is average of y variable minus intercept times x variable. So if we use this formula, then hand calculation, then if we have data like this, x and y, and then this one is time series data, x variable based on time, then it change. And then y variable, or 600, 1550, and so on. Then we need xy, we need x squared, and then we need sum of them, and then we need x bar, y bar. So sum of x variable divided by 12, because sample size is 12, 6.5, then x squared, x bar square, 6.5 square equals 42.625. The y bar, average of the y variable, 33,350 divided by 12, that is y bar. So plug in, then we can get formula like this. Y equals A plus BX equals 441.7 plus 359.61 intercept and slope, then X variable. So using this formula, we can forecast. So if we go back, I will write down. Okay, Y equals 441.7 plus 359.61 X. And change the screen. Okay. So intercept is 441 and then increase like this. So this is forecasting Y. And then maybe a actual like this. Then we have 1, 2, 3, 4. So we plug in here 1, 2, 3, 4, and so on. Then we can get forecasting. This is Y1. Internet connection was a little bit slow now, but it came back. So Y2, Y3, and so on. So if we use X variable in relevant period, then we call this up to, we use the sample. Up to this point, they are, we call that interpolation. Interpolation. And then out of this range, from 13, 14, and so on, we call this extrapolation. So we can forecast using this formula we developed, and we can forecast like forecast demand for March next year. So because this one is time series data, so next year's January X variable is 13, 14, 15. So we can plug in X variable for 15. And then we can get forecast next year, March. So this is like a extrapolation. Inside that is interpolation. Okay, using a formula and then hand calculation, it takes long, tedious job, but I will show you using Excel. Excel file 3. I'm sorry, if you use Mac, then because I didn't use Mac, so I don't know how to use the Excel add-in. I should buy one back, and then I should try to teach for whom has Mac. But based on this PC Excel, then we can use either like a basic Excel data analysis function or a megastat or any other like SPSS statistical tool. I will use this data analysis basic tool. Click this one, and I cannot make this one bigger, but find regression analysis. Click OK. Okay, here, y variable and x variable. By the way, this x variable is not numerical data. So before we use this one, we should convert this one. So cancel. So we need the x variable, not text data. Use like numerical data. So 1, 2, and then type 1 and 2, and then dragging down, and 12. So now we can use data analysis. So regression, okay. And we can specify input range, y range. I include a label and x variable. And then because I include a label, so check label. Then I will produce that output in the same workbook. So I will click here. And others, no, this time we don't need another output. So just basic output. So click OK. Okay, here from this output, we can develop the equation. So y equals A is intercept, so coefficient is 441.667 plus this one. The sign is positive, so plus. If this one sign is negative, then negative. Positive 359.61 x. So if we calculate the March next year, then x equals 15. So we can do it like here. So if we want y March equals, then equals sign and intercept plus open parenthesis and this one Because the x variable is now 15, so type 15. So using this data analysis, then we can get output, and then using output, we can develop the equation. Then using this equation, we can calculate. You don't have to type 441 and so on like that. Just using this one, so click this cell, and so on. So if we do like a 13 extrapolation, 14, and so on, and we can maybe we can do it like equals that one again and again. Make, plus and this one also plus after the reference and then times this value, enter, and so on. Then you may change or you may use if you have a megastat and make it easier, megastat, and relation. Where is the relation? Here, relation. Then x variable, not that one. X variable is 1 to 2. Y variable. And then if we want to forecast using x variable, then type in a predictor value, and then 15, because March next year's value is 15. And then others, this time we don't need, so okay. Then output gives when the output the same as the regular Excel data analysis, and then moreover give this forecasting. When x equals 15, predicted value is this one. So okay, question? Okay, good. Then always I say sorry when I give you an assignment. There is an assignment from this chapter. This one, similar, using Excel data. And I made an kind of a spread table. So you type in some and then like this. And then the question. Looks like this. So Question are basically 3 questions using 3 months moving average, exponential smoothing with trend, FIT, and linear regression analysis using this one. Find forecasting for which one? January, next January. And complete, and then upload only Excel file. Excel file. Okay, any question? Okay, if you don't have a question, then that's all. And then let's talk about the topic of your team projects. Okay, I will find your list. Okay. Any question or any? Where is my the list? Okay, using setting up the file. Let's start from team 1.
Did you hear me?
Yeah, I can hear you.
Okay.
Team leader lost. Kenny, are you there? No. Parameshwara? Paramesh? Are you there?
Hey, hi, Kim.
Yeah. Can you tell us, actually, can you tell us about what you brought as a operations management this topic?
I honestly haven't selected anything yet.
Okay.
Um,
Okay, good.
Yeah, I haven't selected anything. I'm working on
Okay.
it. So,
Okay, good.
I didn't know that. Are we supposed to submit it today, or I didn't know that?
Not something. Bring your thinking. Okay. About Leah. Can you hear me, Elia?
Yeah, I can. Can you hear me?
I can hear you, but a little bit low. So I will increase my volume.
Okay.
Okay.
Can you hear me now?
Yeah.
Mm-hmm.
Still, I can hear you.
Okay, great.
So tell us what you brought.
I read about a case for Starbucks about
Starbucks?
yeah. So before 2008, Starbucks was not as popular, and then it really grew popular suddenly in 2008. So the supply chain management of Starbucks could not really keep up with the growing demands of the customers. They could not supply the products that the customers demanded on time. So so that's the
Okay.
case. And then after that, they created strategies of how they could make the logistics and the supply chain better, faster, cheaper. So it could improve the whole system. So I got
Okay.
that. Yeah.
Okay, hold.
Okay.
Okay, Elisa,
Could you guys hear me?
your turn. Yeah,
Okay.
I can hear you. I can see you.
I didn't research an existing case, but I kind of took guidance from the PowerPoint about the kiosk idea. So I thought maybe on Marywood's campus, how the Nazareth cafeteria, sometimes the line is just so long because there's only one or two people working to swipe your card for you. But maybe if they had kiosks and then a way to select pacer points versus
Okay.
meal.
Yeah, I understand.
Yeah.
Um.
About.
Okay, good. For Elia, your case is like a kind of existing and then a very popular operations management case. So I rather choose Elisa's case. So, but this time your class is not research class, so you
Yeah.
don't need the data.
Yeah.
But Elisa, you don't need the data,
Yes.
or and then this time because it is pandemic, so you cannot contact those people, or you cannot get kind of actual data. Because this one is not research course. So build up case with your expectation. So your expectation is like if that cafeteria use a kiosk, then waiting time shorter, right? And
Yes.
then process fast. That is your expectation.
Yes.
So find previous research or cases similar cases. Maybe you can find any fast restaurants such as McDonald's, Wendy's. They use kiosk, right?
Yes.
Not gentleman order, just enter, then screen, and then touch, and then order like that. So maybe you can find McDonald's or any other such as Wendy's and I don't know if Burger King use that kiosk. So in those previous cases, so you expect if Marriott University cafeteria use that technology, then maybe shorter waiting time, process time shorter, and so on. That means faster, right?
Mhm.
So it is kind of faster case, and then bring other previous case. So it's like we expect like this, but we don't know. But using others, then because they did such, and then that is benefit, so we will get that benefit if we do like. Okay, team 1 done. How about team 2? Just a moment, I will bring up your team 2 list. Okay, Sujar, are you there?
Yes,
Okay. Did you bring any topic?
yeah, I bring one topic about for the Taco Bell for the like a fast
Taco
food
Bell?
restaurant. Yeah,
Mm-hmm.
so over there, that's like before, like maybe in 2019, I guess I believe it. So over there, there's like a
Mm-hmm.
no kiosk uh for
The
that
same
ordering.
kiosk.
Yeah, so
Mm-hmm.
over there for the if you go for in a lunchtime, yeah, in a dinner time, so they have like a two big line for the drive through as well as in dining. So
Mm-hmm.
that's the how to we reduce for that
Okay. Mm-hmm.
line and for that.
Okay. Hold on.
Okay.
So, how about Lottie?
I have one actually from work, where
Mm-hmm.
it's for a bandsaw blade, and we add an additional operation onto a bandsaw blade, and we have no
Mm-hmm.
way to handle it. So everything is handled manually. The specification is handled manually,
Mm-hmm.
manually, customer service, the weld center, the shipping, everything is
Okay.
manual. So I was thinking if we had some kind of portal or an app to keep track of all of this, it would save a lot of time and money, I think.
Uh-huh. Very good case. So hold on. How about Brandon? Are you there? No. How about Zena?
My idea was basically just extending the hours of the Learning Commons on the weekend.
Mm-hmm. Why?
Because that's typically when a lot of, like on Sunday nights, a lot of kids will go to the library and spend
Mm-hmm.
long nights there.
If extended that time, then what can we expect in our operations management perspective?
Like more employees, you'll probably need.
My thinking, if extended that opening time, yeah, library, and yeah, customer service, or maybe if student use that time for study or research or whatever, then benefit will be students performance improve and so on like that, but not much feasible benefit in terms of operations management. So
Okay.
I think for team 2, Lori's idea. So Lori, now using like a manual control, then you consider using like automatic, using kind of app or something. I don't know what kind of app or program implement.
Mm-hmm.
But if you can find similar case, so not exactly the same function or not exactly same area, maybe you can find, because you don't know the results, even you implement that kind of automated things, you don't, you can expect, but because it's not implemented yet, so you cannot get data. So project is like the starting point is like that. There is a problem. Then how can solve or improve that? So using certain technique or a tool concept, that is operations management. So that is good. So find previous case or research, similar one, and then you can adapt that. So it's like in operations management perspective, I work for a company, and then they give me a project improving certain areas, and we can research if we can bring the technology, then we may increase or decrease cost, whatever. We can expect like that. Then we should prove, because they did this one and then they got that benefit. So connect like this, okay?
Okay.
So even it is not an actual, but you can research like that, right? Then make a recommendation. So that is your kind of an operations management project. Okay, so discuss with your team members, but I think this is the best for your team. Then what do you think?
Yeah, that sounds good.
Okay, good. So team 2, and also you know, Sujar's idea similar to team 1, but Taco Bell's idea is the topic is kind of existing case. So Lori's idea is the best. Okay.
Okay.
And I bring up. Yeah. By the way, who is leader in Judy?
Eric, I think I'm almost positive I'm the leader.
Okay.
Yeah, I'm the leader. I just looked back to the first day of class.
Daniel, are you there?
Oh, I'm sorry. Did you say Daniel?
Yeah.
Okay, yeah, I'm here. So my idea was I was thinking about looking kind of at the supply chain of hospitals and seeing how well they're able to get supplies, and especially the protective gear, the protective equipment for COVID, and kind of looking at the supply chain and seeing that.
Okay, hold on. How about Pascal? Is there? Are you there?
Yeah, I'm here.
No? Okay.
Yeah.
TJ.
Yeah, on my phone.
Okay. Okay.
So I was kind of thinking similar to the idea that you had last week when you were saying you're trying to leave class. I know when I go to sporting events or concerts, trying to get out of parking lots is always a jam. So if there's a way that something could be created, like not exactly sure how well it would work, but like an app where each parking space you have a designated leave time after the game or something. So that way you're not everyone's trying to leave immediately. You have to maybe wait a little bit to leave right after, but hopefully it won't back up traffic and could be more efficient than everyone trying to just leave at the same time and pull out and just not really have a system behind it.
Yeah, good idea, but this time to make that case in pandemic now, so, and then that event is not often now. So maybe that is to make. How about Eric?
Can you hear me?
Yeah.
Okay, so I was thinking about something along the lines of like if we use technology or like AR to be able to speed up processes in manufacturing, such as like when you wear like smart glasses that show where to put some or certain parts into something, and that be able to like speed up the processes inside, like internally inside the manufacturing plant, to be able to them to be more efficient. Something along those lines. Hello?
You're on mute, Dr. Kim.
You know, certainly my Zoom close and then come again. I don't know why, but
Do you want me to repeat it?
I heard some parts, but you know, Team 3 all topics, somewhat serious topics. Yeah, kind of the own topic and okay, but with a short time, I think it's harder to develop that case. So what do you think? If I give you one, something like this, you know, this time because of the pandemic, many people use an online order. So for Team 3, many business built online order system this time. So if you can, so it's kind of search what they did or what they do, and then what is kind of benefit this time. So online order development. So search existing cases, as many as online order related.
Perfect.
And then connect those cases with an operations management perspective. Is it okay?
Yes, sir.
Okay. So Team 3, discuss with your team members. Then if you decide like that, then with this, my suggestion, go on. Okay.
Okay.
Okay, good. Thank you. And Team 4. Who is leader? I didn't indicate who is leader. Maybe Ryan?
I know I'm not the leader. I can't remember who the leader is, but I'll go.
I don't know. I don't remember neither.
All right.
Okay, Ryan, do you have an idea?
Yeah, so where I work at Prudential, there's a couple different operational areas, but one of them that I worked in for quite a while was our call center, contact center. So it was always a challenge to forecast scheduling for to staff a contact center with 300 people because of the variables of call type and call duration. Call volume comes in at different intervals based on the day, based on the day of the week, based on, seasonal. When there's tax season, there's even higher call volumes, or quarterly statements get sent out. So it's essentially would be a case study on call volumes and in scheduling, right, representatives so there's not backups and queues, and customers aren't getting upset that they're waiting, right, waiting too long.
Wow. Kind of big project. Maybe you need a queuing system, you need a scheduling, and so on. But if you can do, it is like a real case. So and then if you take a research methodology class, then that can be a good research topic too. But I'm not sure if you can develop a case for operations management in short time. So that is kind of doubting. Okay, hold on. Isha, are you there? Okay, how about Krankuma Hotel? Oh.
Maybe I could just join another team.
Okay, Isha and Krankuma. Okay, hold on, and then your Ryan, your case is very to me very attractive, but it's kind of big and then serious. But to handle as a case for the class work is not too large. So I will think about, okay, then I will give you if I can find a case for you, your team, then I will tell you next week, okay?
Okay.
Or otherwise, then join other team.
Yeah, now just can join another team. That's okay too.
Yeah. So this time only 3 team members, so I can give one by one.
Yep.
Okay, good. But don't worry, okay? Don't worry.
All right. Can you talk just for a couple? Can you talk for a couple minutes about what what's the output? Is it a PowerPoint presentation or a paper, or like the case study? Is
no
it
paper?
No. Okay.
Just make the PowerPoint.
Yeah. Okay.
Based on what topic, and then why you do that, and then what is the problem, what is the expected benefit, what kind of technique tool you use, and then if you can like some cases, previous case bring up and match like that.
Oh, okay. Okay.
Maybe less than 10 page of slides, and just about 10 to 15 minute presentation, and then that's all.
Yeah. Okay. All right. That helps. Thank you.
So it's like an if this is only the undergraduate level class, then just give you idea, then that's it. But because it is upper level graduate level, so I will let you use your knowledge, learning, and then not many, but I brought some cases in the previous and then the existing cases in operations management. So show what they do, and then based on your knowledge, and then based on knowing what they do, then build up your operations management case. So that is like a test view, and then practice you using what you learn. But that purpose. But if you do something serious or a big, large topic, then it takes long. So for class purpose, then that is yeah, yours very good idea and a good case. So maybe if I'm then I may involve that project. Then maybe we can develop case, real case like that.
Yeah. Okay. All right. Then we can just talk
Okay.
next week about it. That sounds good.
Okay, I will think about it, and then next week I will tell you. Okay.
Very good. Thank you.
Okay. Any question or concern? Okay. That's all. And then thanks everything, and then see you next week. Okay.
Okay. Sounds good. Thanks, Dr. Kim.
Bye.
Bye.
Bye, Dr. Kim.
Bye, Dr. K.
Bye. Okay.
Good night.
Bye.
Good night, Dr. Kim.
Good night.
Good night.